Let us do some more examples. I'm doing question number 24 from the book. Okay, first. So here dx over x times natural log of x square. Okay, so you don't need 2 dx. You can write 1 over here. Okay, dx over or 1 over and then dx. It's the same thing, right? Write 1 over. Okay. So here again, there is no function in the denominator whose derivative is in the numerator. If there was no natural log of x, then x, 1 over x, we know that, right? But there is natural log of x as well. So we need to do substitution first. So set natural log of x equals to u. Find the derivative, 1 over x dx will be du, right? So you see that 1 over x dx will be du, and that will be replaced by u, right? That will be u, and then 1 over x dx will be du. So this integral can be written as 1 over u square times du. That's what you get, right? Because 1 over that is u square, right? And then 1 over x dx will be du. So that's what you get. So it will be u to the negative 2 du, right? What is the integral formula there then? That can be written u to the negative 2 plus 1 over negative 2 plus 1 plus c, right? So what do you get? That will be negative 2 plus 1 will be negative, and then you can get u to the negative 1, right? So u to the negative 1, it can be written as 1 over u. So it will be like, this is 1 over u because it is u to the negative 1, and then there is a negative 1 here, so that is negative 1 over u plus c. But what is u though? U is natural log of x, right? So negative 1 over natural log of x plus c is the final answer. Okay guys, so let us do question number 25 from the book. So here again, there is no function in the denominator. You can use that natural log format. Okay, so there is no function in the denominator whose derivative is in the numerator. So what I'm going to do here is I'm going to assume that this is u. Okay, then what do I get? Set 1 minus 3 root under x equals to u. So what is that root x means? You can write this as 3x to the 1/2. Root x is x to the 1/2, right? Now find out the derivative. So what do you get? The derivative of 1 is 0, and negative 3 times the derivative of x is 1/2 x to the 1/2 minus 1. That is the derivative, right? And then dx will be du. It is like a differential, right? Because you will get du over dx, and then I'm just writing in the differential form. How much is that? Negative 3/2 and then x to the negative 1/2 dx equals to du. Did you see that? So how do I write this without negative exponent? So you should move this to the denominator, right? So how do you do that? Negative 3 over 2 root under x dx equals to du. But there is no 3 over 2. So I want to find out, how can I write 1 over root x dx? So how would you write that way then? So I just multiply both sides by negative 2/3. Then you will get 1 over root x dx equals to negative 2/3 and then du. So for this you will write u. For 1 over x root x dx, you will write down negative 2/3 du. So what is the integral look like? So integral, that will be 1 over u times, because 1 over u, that is u, times 1 over root x dx. 1 over root x dx will be negative 2/3 du. Okay, since this is the number, I can pull that down, negative 2/3, right? And the integral 1 over u du. You see that? So negative 2/3 is same. What is the integral of 1 over u du? That is natural log of u plus c, right? Now plug in back the value of u. 1 minus 3 root x. That will be negative 2/3 natural log of 1 minus 3 root x. And then plus c. That is the final answer. Okay guys, so let us do question number 29 from the book. So see this is a little bit different. There is like similar thing on the bottom, but there is no 1 over root x. So how do I handle that? That's the thing. So solution again, here set 1 plus 2 root x equals to u. Again, similar to the previous one, 1 plus 2x to the 1/2, right? Equals to u. Now find out the derivative. I'm just differentiating every time I'm differentiating, right? Here also I'm differentiating. Here also I'm differentiating on both sides, finding the derivative on both sides. Derivative of 1 is 0 plus 2 times 1/2 x to the negative 1/2, right? 1/2 x to the negative 1/2. What do you get? Basically there is you get 2 and then times 1/2, that will cancel out, 2 and 2 will cancel out, right? And then dx will be du. See that? So what do you get? You get 1, so 1 over root x, because when you move that to the denominator you will get root x, right? 1 over root x, and then dx will be du. But there is no 1 over root x there, because we will be replacing whole thing by u, and there is nothing left, just dx left, right? What is dx then? Dx will be root x times du. But what is root x? You need to solve from here. Let me solve from here. Let me use different color. So what is 2 root x? So if you subtract 1 from both sides, you will get 2 root x will be u minus 1. So root x will be u minus 1 over 2. So basically this can be written as, sometimes you have to use this way, right? It's a little bit tricky, you see that? So root x will be u minus 1 over 2 and then du. Okay, so the idea here is whenever you use the substitution method, after you substitute that x, function of x equals to u, you don't want anything in terms of x to be left there, to live there, okay? So what we want to do is we want to change all the x in terms of u. That's why I was getting root x du, but I replace that root x by u minus 1 over 2. So hence what do you get? So thus so integral, so that can be written as that dx is u minus 1 over 2, u minus 1 over 2 du, and then the denominator thing is u, right? So what do you get? Let me pull that 2 out. 1/2 integral u minus 1 over u du. Okay, so what do you get? So 1/2 is 1/2, and then what? You get integral. Let me just write down. Let me write this. This is fine. So you can write u over u is 1 minus 1 over u du. What I did, I split the denominator. I wrote u over u is 1 minus 1 over u is 1 over u du. So what is the integral of that? 1/2 is there. Integral of 1 is u. Let me write inside the parenthesis bracket. And integral of 1 over u is minus natural log of u. And then plus c, right? Plus c. Let me write down that way. So what will be the very final answer? You replace back the value of u. You write 1/2 and bracket. So what is u? 1 over 2 root x. So 1 plus 2 root x. I'm sorry. 1 plus 2 root x. And then minus natural log of 1 plus 2 root x. Close the bracket and then plus c. That is the final answer. I'm sorry, I ran out of space a little bit here, so I need to squeeze everything here. But the idea is same, but so you see that every problem, it is teaching you slightly different techniques because the problem is slightly different there, right? So that's what I suggest. So I suggest people do as many problems from the book as possible, so that every problem teach you new skill, a little bit slightly newer skill, and then so that you can basically learn that. Okay. All right. So that was example 29. Now I want to do problem number 36 from the book. This has a trig function. Okay. So far we did algebraic function or transcendental function or any type of non-trig function. Now I want to do one trig function. So what I want to do here, you see, is secant x over 2. You know what is the antiderivative of secant, right? So what is the antiderivative of secant? It is basically Let me show you that. Antiderivative, or what is the derivative? You see that derivative of secant x is secant x plus tangent x, but the antiderivative of secant, do you remember we did in the last slide? It was natural log of secant x plus tangent x, right? But you have x over 2, so you need to again do the u here. Set u equals to x over 2. Then what will be du? Du will be 1/2 dx. So it will be 2 du equals to dx. So instead of dx, you will be replaced by 2 du. So this will be integral of secant u, and then dx will be 2 du. I'm writing that 2 on the front because it is a number, and then du. So what is the integral of secant u? That will be 2 natural log of secant u plus tangent u. Okay, so what is the final answer? Just replace that u by x over 2. 2 times natural log of secant x half plus tangent x over 2 plus c. That is the final answer. Plus c is here too. Okay, so next is question number 47. Here f double prime of x, second derivative is given, and you need to find out fx. So you need to integrate twice, but we'll use for each of those, you will use that constant, that initial value to find out the constant. Okay, let us integrate. What do you get? If you integrate on this side, you will get the one derivative will cancel with the integral. So what is the integral of 2 over x squared? So you can write 2 over x squared. That is written as 2 integral x to the negative 2 dx, right? So that will be 2 times x to the negative 2 plus 1 over negative 2 plus 1 plus c. So what do you get there then? So basically you get negative 2 and then sorry, f prime of x, because there is f double prime, right? So when you integrate, one of the derivative will cancel out, just only one derivative left. So 2, and then what do you get? So this is negative 1 on the denominator, so I wrote negative 2 there. X to the negative 2 plus 1 will be x to the negative 1, so that you can write 2 over x plus c. So we want to use this condition to find out c. So using f prime of 1 equals to 1, we get what do you get? So this will be x is replaced by 1, right? X is replaced by 1, f prime of 1 will be 1. So you write 1 equals to, so negative 2 over 1 plus c. This implies c equals to what? C equals to 3, because you see that you add 2 on both sides, c equals to 3. So what is f prime of x then? Therefore f prime of x equals to negative 2 over x plus c. But we want to find out fx, so we need to integrate this again. So what do you get? Again integrating, I'm saying integrate here and then here, integrate. If you integrate, you will get fx equals to, what is the integral of negative 2 over x? You will get negative 2 natural log of x. Okay. Oh, by the way, this is not c, this is 3 now, because we already find out the value of c, that is 3, right? 3. So what is the integral of 3 is plus 3x. Now use that. F at 1 is 1. So f at 1 is 1 implies replace f x by 1. So f1 will be 1 and x by 1. That will be negative 2. Natural log of 1 is 0, right? So it will be plus equals to 3. By the way, plus c again. Plus another c, okay? So 1 equals to 3 times 1 plus c. What do you get for c? C will be negative 2. This implies c equals to negative 2. Why? Because you subtract 3 on both sides, right? So c is negative 2. Because this is different from that c, okay? If you want to, you can write d instead of c and find out that d, okay? So d is negative 2, and now plug in back. Therefore, hence fx equals negative 2 natural log of mod x plus 3x minus 2. That is the final answer. Okay guys, so let us do question number 55. Let me use different color so that you can see it easily. So what do you think you should do for this one? This is very straightforward. How? But this is a definite integral. Okay, so 0 to 2. So what we cannot find out, because you see that the numerator and the denominator, so numerator has bigger degree, so there is no derivative of the denominator in the numerator. So what you can do here is you try to simplify like this. Just use any techniques that you want to simplify. Okay, x square minus 1 over x plus 1. That's what I'm doing here. And then let me write here so that I'll have space for the later use. 0 to 2, you can write x square minus 1 over x plus 1 minus 1 over x plus 1 dx. Okay, so there is integral. So what is x square minus 1? That is like x minus 1 times x plus 1, right? This is x minus 1 times x plus 1. So if you cancel that, x plus 1 is x plus 1. So what do you get? X minus 1 is left, right? So let us do that. Integral 0 to 2, and then x minus 1 over x plus 1 dx. Now again, now we try to find out the integral. Okay, so let me write down right here. Okay, right here. After that I write on here. Okay, so what do you get? So integral of x is x square over 2 minus integral of 1 is x, and integral of 1 over x plus 1. What is the integral of 1 over x plus 1? The derivative of the denominator. X plus 1 is in the numerator, right? So it is like when you distribute this, it is one integral here, one integral here, one integral here, right? So you will get the derivative of the denominator is in the numerator. So you can write minus natural log of x plus 1, and but the integral, the limit of integration is 0 to 2. Okay, now you plug in 2 first. What do you get? That is equals to, plug in 2 for each of those x, and then we will plug in 0. That's how the definite integral works, right? Plug in 2. 2 square over 2 is 2 minus, this is just replace 2, and then minus natural log of 2 plus 1 is 3. So you don't need absolute value because 3 is positive number. Now plug in 0, you will get minus, and then plug in 0 minus 0 minus natural log of 0 plus 1 is natural log of 1, which is also 0, minus 0. Okay, so this is all 0, so negative 2 minus 2 plus 2 minus 2 cancel out, so the final answer is negative natural log of 3. That is the final answer. Okay, so similar technique will be used for question number 56 as well. So how do you do that? Let me do that. So you have the same degree on the top and bottom, right? If the bottom degree is smaller than the, if the numerator degree is smaller than the denominator degree, then you start the way that maybe the derivative of the denominator is in the numerator, but they have the same degree. Here the top has the higher degree, so we need to write you can do the long division and then do the way that we did in the last slide, or do this way. Okay, here also what I'm going to do is going to do 0 to 1, x plus 1 minus 2 is x minus 1, right? And divided by x plus 1. Just try to simplify the way that you know. Okay, and then 0 to 1, these are a little bit tricky problems, so you split the denominator. You can write x plus 1 over x plus 1 minus 2 over x plus 1 dx. Okay, so this is just 1 because x plus 1 divided by x plus 1 is just 1. What is the integral of 1? Is x, right? Alright, x minus, again there is 2, so 2 over x plus 1. If you just separate this integral here and here, what do you get? You get that integral is 1 is the integral of 1 is x minus, you can write 2 and then 1 over x plus 1 is similar to that, right? So natural log of x plus 1, but the limit of integration, don't forget that, 0 to 1 for both of those, right? For both of those. Now plug in 1, you get 1 minus 2 natural log of 2. I didn't write absolute value because 2 is a positive number. And plug in 0, you get 0 minus 2 times natural log of 1 is again 0. So that will be just, this is the final answer. Okay guys, okay, let us see a couple more examples here. Okay, and then that will be the end of this video. Okay, So let us do question number 64. Here you need to find out f prime of x. We need to find out the derivative of f, uppercase fx, right? So how do I do that? We know the formula. If there is like the derivative of the integral, derivative of let's say a or 0 to g of x, and then if there is f of t dt, if you're finding the derivative, then the formula is you just write down f, but instead of t you replace by gx, f of gx times you do g prime of x. That's the formula, right? So you can do this by this substitution method again, okay? Change of the variable. You can show this formula by using the change of variable. But let us use that formula. So this is like f, this is like f, right? This is like g, right? So in f, wherever there is t, you replace by x squared. So the final answer here, so the f prime of x will be 3 over x squared plus 1, okay? And then times g prime of x is the derivative of that will be 2x. So the final answer is 6x over x squared plus 1, okay? So next is question number 70. Find the area bounded by that. So if I plug it in my calculator, if you plug in that in the calculator between 1 and 5, the graph look like this, okay? So you are trying to find out the area bounded by 1 and then 5. This is y equals to 0, correct? So this is y equals to 0, and then this is y equals to 5x over x squared plus 2. So you are trying to find out the area bounded by that, okay guys? So how do I do that? To find out the area, basically it is the definite integral, okay? So the area is equals to 1 through 5 and then 5x over x squared plus 2. This is basically the application, right? And then dx. So you see that? So how do I find out this integral? So is the derivative of the denominator is the numerator, because the numerator has one smaller degree than the denominator. So you can think of maybe the derivative of the denominator is numerator. So that you can change this into log, right? So let me pull that 5, this 5 on the front. Then you can write 1 through 5, okay? And then you can do x over x squared plus 2 and then dx. What is the derivative of denominator? That is 2x, but we don't have 2. But we can make it 2. How do I do that? Is you can write 2 and then 2 times x and then divide by 2, right? Now you balance it by dividing by 2, but 2x we need because the derivative of the denominator is 2x, so that we can write this as a log, okay guys? So how do we write that? Then 5 over 2 and then natural log of the denominator, x squared plus 2, okay? We don't need plus c because it is a definite integral. If you write c, but you will plug in 5 and then plus c, and then when you do minus and plug in 1, that will be minus c, that will cancel out. So what I'm going to do here is I'm trying to put that limit is 1 through 5. Now I want to plug in 5 first and then do minus, and then I want to plug in 1, okay? So let us do that. That is 5/2 is there. Plug in 5. What do you get? Natural log of 5 squared is 25 plus 2 is natural log of 27. You see that? And then minus, plug in 1. You will get natural log of 3, right? But do you remember the properties of the natural log? Natural log of x minus natural log of y will be natural log of x over y, right? So that will be 5/2 is there. Natural log of 27 over 3, that is 9, right? That is 9. So what is natural log of 9? It's just keep it. So 5 over 2 natural log of 9. Or if you want to, you can still do like this. 5 over 2 times natural log of 3 square. So 3 square, that square come to the front, right? That square thing come to the front, and then you just remove that. So you cancel 2. So 5 natural log of 3. You can write that way too. 5 natural log of 3. That is the final answer. You can write the final answer that way too. Okay. And the very last example from section 5.2 is find the average value of fx in the interval 1e. So how do I find out the average value? The formula for the average value is 1 over b minus a in the interval. average value of a function fx in the interval ab is 1 over b minus a, and then a to b fx dx. Okay, so area divided by the length of the interval, because this is the area divided by the length of the interval. Okay, so how do I do the average here? Then average is equals to 1 over e minus 1 b minus a, and then 1 through e natural log of x. Oh, by the way, there is 2 natural log of x over x, and then dx, right? So how do I do that? 1 over e minus 1. E is a number between 2 and 3, right? Its value is like 2.71. And then let me pull that 2 out. So it will be 2 over that. And then 1 through e, natural log of x over x dx. Okay? So tell me, how do I find the integral of this? Is the derivative of the denominator function is the numerator? No, because the derivative is 1. Derivative of x is 1, right? So it is not there. So how do I do that? Again, do the u substitution. So set natural log of x equals to u. What is the derivative? Find the derivative here. Differentiate 1 over x dx, because the derivative of natural log of x is 1 over x, dx equals to du. So 1 times over x, dx will be du, that will be u. So what do you get then? That will be 2 over e minus 1. Okay, and then you can write 1 over u. By the way, not 1 over u. That will be this is u, and then that is du. U du, because natural log of x is in the numerator here, right? What is the integral of that? That will be 2 over e minus 1. Oh, by the way, I forgot. Oh, I will not. So you can change. There are 2 ways, right? You learned that in the chapter 4 of the calculus 1. You can change the limit 1 through e for u, 1 and e for u, or you can just don't write down the limit here, because we are writing in terms of u. You will plug in back in terms of x and then use the limit after that. Okay, so it is u squared over 2. Okay, I'm not writing plus c because we will have to plug in the limit. Now that will be the 2 and 2 will cancel out. So you write 1 over e minus 1 times u is what? U is natural log of x. So natural log of x square. U square is that, right? Then what? What is the limit? Don't forget the limit. 1 through e. That is limit for x. So I did not put that limit here because I changed to u. Or you, if you want to, you can replace the 1 and e by the limit corresponding to that, because if you write x equals to 1, you will get u equals to 0, and then if you put x equals to e, then you will get u equals to natural log of u, which is 1. You can write 0 to 1 here, or you can go back and then use the limit of x after you replace natural log of x back. So you write 1 over e minus 1. Now plug in e. You write natural log of e is how much? 1, right? 1 square is 1 minus natural log of 1 is 0, so 0. That's what you do. So basically your final answer is 1 over e minus 1. So this is how we do the integral using natural log. Okay, again, the big formula here is, if you have a function in the denominator and if you have its derivative in the numerator, then the integral is natural log of the denominator function. I used u earlier, but here I used f. It's the same concept. Okay, that is the big formula that you learn on this section, and other method was just the regular you learned in calculus 1. Okay guys, so if you get any questions, just email me or come to the Zoom meeting so that we can discuss. Okay, all right, thank you very much.